Hi everybody. So we're going to look today at inequalities and equations with absolute values. Now the first thing is, remember, the absolute value of a number is just the same number except it's the positive version of it. So for example, the absolute value of 4 is still 4. The absolute value of 2.1 is 2.1. The absolute value of negative 3.5 is positive 3.5. The absolute value of negative 7 is positive 7. The absolute value of 0 is 0. Okay, let's look at the first equation. Now, the absolute value of x is 3. So we want to think, what are values of x such that if we take the absolute value of them, we'll end up with 3? Well, 3 is definitely a solution because the absolute value of 3 is 3. And negative 3 is a solution because the absolute value of negative 3 is also positive 3. Okay, let's look at our next equation. The absolute value of x is negative 2. Now in this case, there is no solution. I cannot think of any number where if I take the absolute value of it, it's negative. The absolute value is either a positive number or 0. The absolute value can never be negative. The absolute value of negative 7 is positive 7. The absolute value of 5 is positive 5. The absolute value of 0 is 0. So there is no number where the absolute value is going to be negative. Okay, let's look at our next equation. The absolute value of x plus 1 minus 7 is equal to 2. The last couple of problems, the absolute value was already isolated when I gave you the equation. Now in this one, the absolute value is not alone on one side of the equation. So what you need to do in any equation or any inequality is you need to get the absolute value isolated. So the first thing we're going to do here is get the absolute value of x plus 1 alone by adding 7 to both sides. So now we get the absolute value of x plus 1 is 9. Well, we're taking the absolute value no longer of x, but of the quantity x plus 1. X plus 1 is the number we're taking the absolute value of. So the number inside the absolute value sign, which is x plus 1, that could be negative 9, because the absolute value of negative 9 is 9. Or the number inside the absolute value, which again is x plus 1, could be a positive 9. So we're going to set up two equations here. We're going to set up x plus 1 is negative 9, and x plus 1 is 9. Solve for x in each of the two equations. We get x is negative 10 and x is 8. So here we have two solutions. All right, next let's look at inequalities. Now these are the harder ones. So we have a simple inequality here. The absolute value of x is less than or equal to 2. Well, let's think about this. What values of x could we plug in for, x that will give us an inequality that's satisfied? All right, well, let's see. If x is 2, the absolute value of 2 is less than or equal to 2. If x is 1, the absolute value of 1 is less than or equal to 2. If x is 0, same thing there. 0 is less than or equal to 2. If x is negative 1, okay, the absolute value of negative 1 is positive 1. That's less than or equal to 2. If x is negative 2, the absolute value of negative 2 is positive 2. That's less than or equal to 2. Okay, and you see I have other numbers there, like 1.5, 0.7, negative 1.9. Now, let's look at numbers bigger than 2, like 3. The absolute value of 3 is not less than or equal to 2. So x equals 3 is not a solution. Let's say x were to equal 2.1. The absolute value of 2.1 is 2.1. That's not less than or equal to 2. Okay, let's say x was negative 3. Now the absolute value of negative 3 is positive 3. that is not less than or equal to 2. So the only numbers that satisfy the inequality are between -2 and +2. And the way we write it is that three-sided inequality, okay, -2 less than or equal to x less than or equal to 2. The smaller number is always on the left, the larger number is always on the right. Okay, how would we graph that? Well, on a number line, I'll draw -2 and +2, and I'll have my graph above the number line to make it clear. Notice there's an equality sign for the -2, there's an equality sign for the 2. If we want to include a number, we have a filled-in circle. If we want to exclude the endpoint, we have an open circle. So here, the -2 and the 2 are included. So notice I have filled-in circles of -2 and 2, and I have a line connecting the two filled-in circles. Okay, let's look at a greater than inequality. So, x could be 3. The absolute value of 3 is bigger than or equal to 3. X could be 3.2. That absolute value is bigger than or equal to 3. X could be 4. X could be 4.1, 5.7, 6, 10, 20. Okay, so far we have numbers bigger than or equal to 3. But let's look at the negative values of x. If x is -3, the absolute value of -3 is +3. And +3 is bigger than or equal to 3. Let's say x is -4. The absolute value of -4 is +4. That is bigger than or equal to 3. Let's say x is -3.8. The absolute value of -3.8 is +3.8. That's bigger than or equal to 3. Let's say x is -5. The absolute value of -5 is +5, bigger than or equal to 3. So what are the solutions? We have numbers both less than or equal to -3, okay, like -3, -4, -5, or numbers bigger than or equal to 3. Okay. And in terms of graphing that, we have two separate regions. So notice here the -3 is still included. Okay, there's a filled-in circle. Less than, I have an arrow going to the left. We want the numbers less than -3. Less means arrow to the left. 3 is included. There's a filled-in circle at 3. Okay, I have an arrow pointing to the right, greater than. So we're going to draw our arrow for the solution to the right. Okay, and for our final example, suppose we have an absolute value inequality, but the absolute value is not yet isolated. So isolate it, add 2 to both sides. This is a less than absolute value. So that means x plus 1, the quantity inside the absolute value, as we saw from a previous example, is between -7 and +7. We have to get x alone in the middle, add 1 to both, subtract 1 from both sides, and you get x's between -8 and 6. Now here, there's no equal sign. -8 is not included. +6 is not included. So we're going to have open circles for -8 and -6.